It's
Can you hear me?
Jessica speaking. Yeah,
Oh,
Jessica.
Jessica. Okay, all right. My name is Olanma Imo, and I'm excited to be here. Some of you might not know me. I think I say familiar um name here. What's it called? Or was it my eyes was playing tricks? Anyway, okay. So, just a quick throwback of who I am or who I used to be. Um, I was with WAAW Foundation for over 13 years, and it's really like a nostalgic, effect right now, giving back and talking to fellows. And I can see WAAW Foundation have expanded to, more countries with the Fellows Summit. The Fellows chapters and scholarship program it's really, big news and impact, giving back and seeing the growth over the years. So today I'll be walking you guys through Tinkercad, and the reason why this topic was selected is we are in an evolving world where technology is like what you eat, breathe, and speak. So I understand that the outreach programs that you guys do, most of the time you have STEM kits. But however, most times you're limited to the number of kits that you have that would go around with the students. If you can't hear me, please let me know in the chat box so I can increase my voice. But okay, great. So in the meanwhile, just in a short while, I'll be sharing my screen. I just want to walk you through what we'll be talking about today. So I've been there, run trainings where we have limited STEM kits. You have excited students. Everyone wants to feel, touch, and build alongside with you. And you only have what? Maybe one Arduino kit or one wind turbine or whatever you have. And it's not enough to make the impact you want as a chapter lead or as a chapter. So what Tinkercad does is it's kind of bridges the gap of having physical STEM kits but also making the same impact. So with Tinkercad, you can do circuit, you can do 3D design. The only thing is just that you're not seeing the physical product. So what that means is, say I give you an Arduino to build a simple traffic light, for example, and we don't have the Arduino in real form, right? We can design it on Tinkercad, simulate it on Tinkercad, make it work. The lights are working, everything are working, and that's it. Sometime in the future or whenever you stumble on Arduino, you don't need to be taught how to use it. So it's just like most architectures and even um, developers, core software developers, robotics engineers, they don't use the actual what's it called physical items to test run like your design thinking process. So they simulate and then they start building because how many products you want to ruin before you can get it. I'm not saying that you don't have to. So this is not replacing the actual thing, right? It's just so if you want to use eco or green or renewability, say you want to like save the planet and reduce waste. But anyway, it's good to have STEM kits, but in a place where it's not enough to go around in your outreach program, you can as well, introduce Tinkercad. Another thing with Tinkercad is, let's say a chapter in Cameroon is doing something and another chapter in Rwanda wants to do the same thing. And there is no time to like sit together to exchange ideas or knowledge. WAAW Foundation probably will have like a Tinkercad community where fellows can go in there and collaborate. So someone from, let's say, Mary Paul from Benin. Is that Benin or Benin? I just want to be sure because the name looks French. I think that's Benin Republic. has an outreach program, and Helga from Cameroon wants to run the same topic in her own outreach. You know, Jessica, on the other hand, will have a pool of what everyone is doing, sitting in one community. So Jessica can say, the Cameroon chapter went out today to do XYZ because she can see the actual work. And if Helga graduates from Cameroon, the incoming chapter leader can take off from there. It doesn't need to be retrained extensively. It's not lost, because we've seen sometimes chapters, there is no smooth transitioning from the chapter lead outgoing to the chapter lead incoming. So when you have that, it gives like the program manager, what's it called? Ease to help coordinate the whole chapter. So that's the goal for this class. So while it's helping, it's also helping the organization at the other end to see what you're doing to ensure that you guys are actually doing work, and also share what you're doing with the external community. Excuse excuse me, I just have a bit of cold. Can you make me okay? I can share, right? So I'll be moving across two screens. So I'll be working on my slide, and also my slide doesn't have like enough pictures. It's an intentional slide because I'll be working more on the Tinkercad dashboard. So I'm not going to be reading through a deck. I'm just using it to guide. Does that make sense? Jessica, can you hear me? Or I'm just speaking to myself.
Yes, I can hear you.
Okay, all right. I just want to be sure, has everyone set up like a Tinkercad account? I asked just Wural to inform you guys. Just in the chat, you can just say yes, or leave a reaction. Okay, great. Ishimwe, that would be Rwanda. I can say the name. Okay. All right, great. Okay, let's go to it. So, Tinkercad. The first time I stumbled into Tinkercad was 2018, and it was like a kid walking into a candy store. I'm like, wow, there's so much we can do here. So Tinkercad, our goal here is to understand Tinkercad and use it, learn basic 3D design principles, simulate simple electronic circuits, use Arduino and code blocks, export the design, if you want to print it. WAAW Foundation has a 3D printer in the Abuja office, and you know 3D printing is not something like, the machine is not something you want to like buy for every chapter. Hopefully in the future, with more funding, WAAW Foundation will be able to do that. But currently, learning how to design is a core focus, and there are, labs that you can collaborate in your country. I know for Rwanda, there is K Labs. I don't know if the Rwanda chapter fellows are aware of that. There's K Labs, and there is Fab Lab. Fab Lab and K Lab are like sit opposite each other. Aphrodis is in charge of K Labs. So you can walk in there, do some networking, and they can let you use their 3D printing. I know they do that. They have a program that they do with university students. So that for Rwanda, I know, but for other countries, I'm not so familiar with that. So it's something you would like to explore if you're in Rwanda. Okay. So and what is Tinkercad actually? It's a web-based design tool, from Autodesk. It supports 3D modeling, circuits, and code blocks. The fascinating thing about Tinkercad is you design and you put the code, you know. You're not just designing like, it's just like using Canva, you're designing a flyer and you want to see it function. I'm not sure why this thing. Just one second. Okay. And it's beginner friendly. And there's a lot of resources on Tinkercad that you can use. There are a lot of collaborators across the world that have free projects, that they have with source codes that you can use to learn. Okay, so let's get right into it. Getting started, you just need to go into tinkercad.com, click, let me show you. Tinkercad. Can you guys see what I'm typing though? Can you guys see my screen? Like where I am currently?
Oh, yes, we can see it.
Okay, all right. So when you get a Tinkercad, yes, I'm just gonna tell you what all these means. You can see my name here. So this is my account. So if you want to go straight to tinkering, you can decide to go to 3D design, circuit, code block, SimLab. There's a lot of Autodesk Fusion, but these are the um three things that you use, you know, mostly on Tinkercad. And there's gallery, there's project. Excuse me, projects. If you come here, you see that projects are in grades. So, for example, you're working with primary school students, your outreach program, or high school or university. You choose the grades, and depend on what you're trying to target, there are Tinkercad for everything. You choose the topic, and then you search. So let's say I'm looking for something for grade 9 to 12, and I'm looking for something under electronics. Okay. I have all these examples I can, you know, look at. Then there are also teachers. If you're a teacher, you want to, use Tinkercad for your classroom, you can connect it to your Google Classroom and you can have your own actual Tinkercad classroom using the Tinkercad platform. And there's a lot of resources that you can take advantage of on Tinkercad. There are free lesson plans. The lesson plans are based on the topic, that are there. So in math, physics, sciences, there's a whole lot you can take advantage of, not worrying about what you want to teach in outreach. But I would like it to be aligned to what the curriculum is. So when if you have a curriculum that you guys are using as a chapter, you can align it back to, okay, we have this curriculum. How can I design something that is real? Like, how can we bring it to life using Tinkercad? You come back, you search that topic here. I'm sure you'll find someone that's done it before, and then you collaborate. Okay. So if you've signed into Tinkercad and you have an account, what you would do, you typically have something like this: your name, new design, my design, notification settings, and my classes. So let's go one after the other. So new design is I want to create something, a 3D design, circuits, or code blocks. My designs are things I've done already on Tinkercad. So on circuits, I use more of the circuits. You could see, some of the work I've done. And code blocks, I haven't really, used the code blocks, but you can also, if you want to do that, if it is your thing, you want to use code blocks and all of that, you can. And you come back to your classes. So I have like two classes because I'm teaching some kids. So I have two classes, the junior and the regular. The senior is supposed to be senior and junior because they are grouped in ages. So this is something you can have. Let's say as a chapter, you guys can have these probably targeted to schools or targeted to ages and say this is for a certain, grade, or you can have it as a WAAW chapter Tinkercad account, and then different chapters come in and put in their work. So you can use your classes anyhow and however you want it. Say I'm creating a class called Wow Fellows. We'll have time to actually work on something today, don't worry. And I'm using this, and I've created, oh shoot, right. heck? I think I need to go all the way down. Create class. Thanks. Let me hide this caption. Is affecting my thing. Not sure why this is going off. Okay, done. Okay, so I've created an account called WAAW Fellows, and I can share this class link. So I would, if you guys can go to your Tinkercad and copy this link, because what we'll be working, I want to is a hands-on, training. So I've copied it. I'm gonna post it on the chat. And I would like to see everyone come in here and join the class. So remember, you don't have to, this is not like the actual WAAW Fellows group. It's just for the purpose of this class. So I've created it. I just want to make sure that you guys understand how to join the class and how to use this. So I'm waiting. If you join, just let me know. You have to be logged in into your Tinkercad to be able to do this. Click the link. Okay, joined. Anna said joined. Why am I not seeing that? Okay. Okay, great. Whoa, that was quick. Okay, great. Can someone mute, please? Okay. I should resend the link. Okay, I'll do it again. All right, while we are waiting for more people to join, I'll just continue. So I'll just let you know what each student means. So Jessica, for example, is my number one here. I can assign something to Jessica. I can add Jessica. She's already added to my class. If she's not, I can add her. Say I manually put it, right? Or so another thing I can do to Jessica is to remove Jessica from class. Say Jessica finished her work, I can award Jessica a badge for doing something. So now your students that have like access to laptops or computer or even phone can you can have a follow-up. Sometimes we do these outreaches and we go and we don't hear back from the students. They want to connect, but we can't leave them with our STEM kids because we need to go to another school and it's not theirs to keep. A way to have that community, the continuation, sustainability is to work with Tinkercad. That way, even when you're not with the school, you can still see what your students are doing. It's kind of like exciting to see that, hey, they're moving from point A to point B and you can assign things to them. Yeah, not everyone will continue or follow through, but the few that still sticks to it, it can become a full-blown thing for you guys. So I can award Jessica, a badge for electronics and it's awarded, okay? Then we have more people here. And okay, now I have an activity I need to assign to this class. And so that would be what our first thing to do. Um, we can have designs, we can have people moderate. So let me assign. Okay, I've created an activity, and if you all can go, can you let me know if you see it? I've assigned it to I've assigned it to this class. Let me know if you guys can see it. Mm. Oh, no code yet. It's only the link to join. There's no code yet. Okay, you can see the. Okay, great. Okay, because that will be what you guys will be doing in the next few minutes on your own. Okay, so I've walked you through how to assign classes, how to take students out, how to add students, and now let's get to the business of today. So this is your roster. If you want to make sure all your students are there, this is their code and everything. Okay, let's get back to it. Okay, so this is a single. This is a. If I want to create something, I have something I've already done, so I'm just gonna walk you guys through it because of time, and then because I want you guys to do something on your own as well. So this is a simple circuit connection using what's it called? Just one second. Using a breadboard. So I'm going to take all this off. Okay, so this is just what we have. And I got these guys from. Okay, they are cool, so I don't want to delete. So Arduino, you want to add Arduino, you just bring out one here. So this is where all your components are. So we call them the basic components, or you choose all Arduino basic. You come to the component and you choose what you want. Okay. So the first step is to bring out the. No, I don't want to delete that. I just want to delete this one. Arduino, and the next step is to bring out the breadboard. You arrange it properly so they are all facing each other. Okay, you can decide to do it like this, depend. But I always like to have my, if I'm not building a lot of, if I'm not in a lot of circuit connection, if it's something small like what we are doing now, I arrange it like this. This is for you to rotate. This is to change the colors. This is to the type of wires you want, alligator clip, hook. So with your actual Arduinos, the components you have. They are all here. Okay, so if you have your alligator clip, this is what it means. If you want to use a hookup, this is what it means. If you want to use a normal wire, which is just the jumper wire, the regular jumper wire, this is it here. You want to put a note to your design, you can put a note there. And if you want to delete, you can delete. Okay, so the next step for us is to get an LED. So I'm building a single LED connection. So I'm bringing an LED. I decide to place it anywhere here. And remember, with this simulation, you don't need to worry about what's your cathode and anode. So if I bring out the LED, it tells me which leg of the LED is my cathode, which leg is my anode. So I put it in the breadboard. Then I use a resistor. Okay, you always need your resistor. I connect my resistor here. One leg going to the cathode, the other one going to terminal 1, which is my negative rail. So it's on my negative rail. Then the next thing I need to do is to connect the anode, the leg of my LED to my Arduino. So we'll be using pin 13. So I click on pin 13 on the Arduino and I drag all the way here. And I drop it. You drag, you drop. I can decide to change the color of this wire. Um, let's say I want orange. That's it. Okay. And now we need to initiate in what's it called? Initialize ground. So our ground is from the negative rail. I drag, I drop because I want to have a neat connection. I drag again, I drop, I drag, I drop, I drag, I drop, I drag, and I put it in the ground. And I usually like it to be black. That's my ground. Now I need to power my breadboard 5 volts going from the positive rail to my Arduino. So I drag again, I drop, I drag, I drop, I drag, I drop, then I plug it in. Once it plugs in, you would feel the click sort of. Then I change it to red. And that's it. We've done a circuit connection. How do we know that if this actually works? We have the code. We have the block, which looks like Scratch. So you're teaching kids that will not be able to type bunch of codes and all of that. You can use this to design that. We also have the code, the actual Arduino code. This is the code. Okay, if you're familiar with Arduino codes, this is what the code for what I just designed looks like. Okay, most time if you're building, you have to write your codes yourself. But if you're simulating from other people's project, which I'll show you how to get other people's project, some of them already have the codes, and some have only blocks and some have only text. So for example, if you're simulating my codes and I only have a text and you click on blocks, you might end up losing my text. So what I always advise is copy out the text, go to your Arduino um, or your Arduino on your laptop or your notepad on your laptop and paste the text just as I'm doing now. I'm going to copy out this so I don't lose it. And when my Arduino opens, I paste. Okay, so now I'm back to my text. And does this work? Did I write a bunch of jargons or is this actual code? I click on simulation. You see, my light is on. If I stop the simulation, it goes off. You can see the change in color. So let me change the color of my LED so you can actually see. Let me change it to blue. No, here. Blue. So I'm going to start it again. See the color changes because it's just on. I didn't like change the code to do off and on, digital right, digital low. Um, I can say, all right, let me stop simulation, and I can change these milliseconds to 100. So what this is saying that I want you to wait for 100 milliseconds, and then let's go back to simulation. Okay. So using what I just did, okay, can you guys go to your classes, your code, and redesign this, just this one, and then we can try adding 2 LEDs and 3 LEDs accordingly. If you have any question, put it in the chat. I'll be looking at it shortly. Wait, can we go through this again? Below you will see your function. Okay, just 1 second. Let me understand what the questions are. Can someone help me with the questions? Amenge is asking. Wait, can you unmute and ask your question?
Amenka is asking if you can go through this again.
Okay, is it the design?
Yes, I think so.
Yes, ma. Ma, I also wanted to ask something. I'm on
Okay.
the link now, but I can't see the new class you created. I can only see join a class, novel, email, and just the front interface. Can't see anything else.
Okay, wait, hold on. You can't see. Oh, if you've joined the class, hold on. This is the class. This probably is. If you've joined the class, you open it. You click on circuit. I've assigned. I've assigned a class to. Hold on. Activities. I've assigned a three-way traffic to your class. Can you guys see this class I assigned actually? If you can't see the class, let me know. If you can see the class, let me know. Just say no, I can't see the class. No, I can't see the activity, or I can see the activity.
No, I can't see it.
No, I
You
can't
can.
see it. I can't.
Okay. All right. I'll sign it again. Wait, someone just designed. Wait, hold on. Someone just designed something. Jessica just started. Let me see. No, this 3D. I think she's just playing around. Okay. Who did this? Amenga did this. So I'm going to. These are your work. So I'm going to reassign this class again. Not sure why you guys are not saying this. Copy to class. Okay, I've copied it to class. When you come to okay, can you go meet your dad? Thank you. When you come to the WAAW Fellows, you see activities. Click on it, you see this three-way traffic. When you click on the three-way traffic, you click on circuits. Then you do your new design. I didn't put any design there. I just assigned you a classwork and I want you to start a new design. So start a new design and choose circuits, and then we can all do this activity on our new design. And it normally just gives you a random name, so always rename your work by. If you name it, you just put by and put your name. Giving it to you. Guys, just 1 second.
Hi, Miss Olanma. If you are speaking, you're on mute.
You're mute.
Good. Okay, Amenga, I was asking, you asked which port did you use to connect the wires? Okay, so this is my for the what's it called? For the LEDs and for the resistors, right? So far that is connected on. Oh, my simulation is on. That's why I can't move. So far it's connected on any pin to my negative rail. My LED has to match it. Same thing with this. So I can decide to, put it up here. So this is, I'm working with A to J and J to A. Everything here, I can work with it. Same with everything here, I can work. But you can only work with negative and positive for your ground. Your ground always has to go to your negative rail, because it's earth. You're trying to initialize earth, that the connection between the Arduino and the breadboard. Same thing with the voltage. The 5 volts is to power your breadboard because there's no current flowing to your breadboard at the moment. So that's what this red cable does. Okay. So this is our circuit connection. What we actually want it to happen. Someone is asking for the code. You click on code, text, and then you type in this code. I'm gonna put it on the chart. So this is a sample code. So I want you to have two LEDs and two resistors when you do yours. Okay, I'm going back to the class and I'm going to so you need to put your work. Okay, this is circuit. I'm saying other people's. This one is not done. Halimat, yours is not done. Christiana, yours is not done. Amazing, yours is not done. Amenge, let me see. Yours is not complete. You still haven't done your. Like, I can come in and actually edit will work. You've done the ground. Your ground is placed wrongly. Your ground is placed wrongly. It's supposed to go from I took out that cable just to show you what I mean. So you see, I can correct anybody's work live. It needs to go to the negative. And then your 5 volts. I'm just gonna do a random stuff. But going there, you can delete and rewire and make it nicer. So I'm changing the 5 volt to red. I'm changing the ground to black. The reason why you want different colors is so you know which with the color which cable goes where. So if I simulate your work, it should work now, if you can see, because my wiring is right. So Amenge, your job is good now. Let me see who else. So go back and do it again. It's the cables are not nicely done. Um, Christiana, you have a bunch of items here that are not supposed to be here. So delete them. You click, you delete, you click, you delete. Now you have an NMP transistor. I think that's basically there's nothing here again. Just you need only 5 things. You need a breadboard, an Arduino, an LED, a jumper wire, and a resistor. That's it. I need to see more people's work. Christiana, you put the wrong thing again. That's not what is supposed to be there. Halima, your work is not there. I'm going back to the chats and can you send the link to join the class? The session, yes. Okay, that's the client. Which pose did you use Canada also? Oh, I'm reading. Okay, does anyone have any question? So far, I'm just seeing people's work, but not at the actual work that I want you to do. Nobody's saying anything. Are you guys all busy creating? You're working in the first class, right? Yeah. She's um we have 45 people on this call and I only have how many people in my classroom? Let me see. Oh wow. Oh my god. Oh, Mirel, why'd you have all this? Oh my god. Delete it and do it again. Amazing. That's not correct. Your work should look like what Amenge looks like. So this is what if you're in the classroom, you see my work. I'm redoing it again. This is what I did. This is what I did. If you put the wrong pin anyway, just like I just did now, right? I can just delete it. Just make sure the wire goes to another pin. Say I mistakenly started a pin drag and that's not what I want to do. I have to put it in another hole. That way I'll be able to delete it. If not, it won't work. I need to reduce. Okay. 5 volts. This is what I did before. Then I connect my ground. Okay, now I'm changing the color to black. And this to red. Now I need my LED. I need my resistor. And I need to connect my pin 13. It can be any number. I can decide to put it on 6. Okay? It doesn't have to be 13. It can be any number. Then, but make sure that in your code, text. Just make sure that in your code, you change it to, what's this now? 6. I don't know if you guys have done your Arduino training, because this is just me putting codes that, in case you don't know what Arduino is or how to use it, this is a total different class on its own, learning, understanding these codes and what pin mode is, what digital write is, and what delay is. It's a different class on its own. I won't be, focusing on that today. The goal of this session is to understand how to use Tinkercad. So I'll circle back with Jessica. I think there should be someone that either the alumni that will be able to, go through these. And also you guys are welcome to, reach back to me on how to use the codes. So I made sure I change all these to 6, and let's simulate. Says working. If my code is wrong, say I put it at 5 and this is 6, it won't work. It will give me an error. So same thing when you're using an Arduino proper Arduino software. So I'm going to come back to the does anyone have any questions? I can't see my work on the screen. Oh wow. I don't understand though. How do I make my 3D? It's not 3D drawing. We are doing circuit. And if I do add another LED, how do I ensure the works? Okay, that's a good question. How do you add another LED? We'll get to that. Let's just finish with the one LEDs first. Okay. If you can't find your work, just create a new design. Okay? Still in this same class, just create a new design, just like this. And choose circuits. That's what you do. Let me say it again. If you want to create a work, okay, I'm going to delete this so I don't have multiple work. If you want to create a work, come to create new design under that classroom link I shared. Okay? And choose circuit. And that's it. I'm going to delete that. I only have 8 people working, and I have 45 people on the call, except maybe you have only 2 WAAW admin here. So let's say I have 43 working, but I'm only seeing, oh, you don't know how to add the classes. What's going on? Okay, let me see what you guys are doing. I'm going to choose a random person here. Okay, circuit. This is what you have. Okay. Okay, you guys are working, but I'm not seeing. No one is doing exactly what I did.
Mommy,
Yeah.
is my blue dress clean?
Your what?
My blue dress, is it clean?
Yeah.
Okay.
Which one? No, it's not. It's not. It's not. I'm in a class. I'll talk to you later, okay?
Okay.
So it seems like everyone has work actually going on, but they're not putting it together. Not sure why someone needs notification. Okay, while you guys are working on it, I want to just show you something, how to get random project on circuit. So I asked you guys to do, so this exactly, this is something, a Tinkercad blinking light. This is around someone's project on 5 LEDs. So it's a PDF version, but with the code, you can view it in 3D, you can tinker it, it has codes, it has the code line, it has the blocks, it has everything. And since you guys have me as a tutor, you can come to my designs, my circuits, and then okay. Okay, I'm going to go to my students. These are like what my 7-year-olds did. Um, so this is how she wanted her wires to be crossed, and these are all designs of my kids. So this is a 3D. Don't know why she wrote it a 3D. This is a 3D or 3 lights. So for someone that asked me the question, this is how you can tinker a 3 LED design. So if I simulate it, you could see it's working. I'll show you what the code looks like. You can see the time lapse. There is a weight and all of that. I put the code. Oh, no. Shoot. I put the code. How can I change? I think it's scratch. I want to change it. Okay. If you want to change it, your code is currently in block. You need to go to text. It's currently in blocks. Go to text and choose text. That's how you can write with your code. My code is in another language which I can't read. Sorry, what's your language? Amenga, what language do you speak? This is the code for a 3D the code. So So this for a 3 LED connection. Oh no, sorry, I copied the wrong thing. The code for this one I just posted is for 3 LED connection, not the first one, please. Alright. Amenga, what language? What language? No, I meant I was reading it in Scratch. Okay. Alright. So I'm going to call back, copy. So it shows that I've copied it. Let me just leave here so these kids won't, get mad that I went to their work. Let me rename it for them. 3 LED try. I have 31 students here, but I need to make sure you guys are working. Wow. Oh my days. That was a lot of. Okay. Morphine Folua. I could see you started with the 2 LEDs, but you put the ground. Okay, but where's the 5 volts? You've not done it. Okay, play with this. And let's see. What else are we missing? Okay, I think this is a duplicate. Let me take out this one. Let's see. Okay, I can see you've added the 5 volts. Let me look at what you've done. Okay, let's tinker. Simulate it is working. And the codes. I'm going to open your work just to be. Let me simulate it and see whether it's working. Right. Okay, it's working. I don't see your code. Okay. Oh wow, that's smart. Okay, good job. I'm going to award your badge. So you see how I can easily review a student work. I'm going to react to it. I can give a star. I can connect it to my Google Classroom. I can tinker it if I want to. I can delete it, but I don't want to. That's not the goal. Good job. So she's the only one that have done the 2 LEDs.
Mommy, look, Doctor is watching again.
I think just
Hi, Miss Olama, you are muted.
hour. I think I'm supposed to make changes to the code because my LED is not responding. Okay, this is the code. I'm posting it again. This is the code for 3 lights. So just you can tweak it for 2. You just delete the last one. So where you have pin 13, 10, 7, just remove 7 and remove 7 also in the loop. That's it. Understood? So where you have 7, delete everything on 7 and just have, if you want to do only 2 light, but if you're doing the 3 light, that's the code I just put. You can switch the numbers depending on where you're dragging your pin to. Any more questions? I think I'm done with the design for today's class. Was it impactful? Did you learn anything? Can I get questions or feedbacks?
Hi guys, good evening, good afternoon once again from my end. It feels like it's really quiet, so this is I'm going to like do some questions directed at some fellows, and so it basically is just to hear from you. So this is, I mean, since I joined WOW in January, this is the first time that we've had an hands-on class in this element of things. So it's pretty new, I would say. But I just also want to check from our fellows: was this a great worth of your time? Is this something that we should continue? And what's your general feedback? We want to hear from you really, because it's important for us to move forward in the next couple of next sessions. So you can just indicate using the symbol that you want to speak. Then we'll let you. We should continue, please. What do you mean? Hi, Dubilia. Do you want to speak so we get more clarity on what you're referring to? Okay, Amenge has question. Hi, Amenge. Can anybody hear me? So just to be sure, Lillian, can you hear me?
Yes, yes, I can
Okay.
hear you.
Okay, just wanted to be sure. Um, please let's continue with such workshop because my course. Okay, okay, got you. What I meant is we should have more sessions like this. Okay, got you guys. Got you on that. Okay, okay.
You were
Thank you.
lost all the way. Why? Someone is saying the Billia said I was lost all the way. How can you unmute the Billia? I want to speak to you directly. Where were you lost? Was I speaking so fast or?
It's pretty
Speak
faint.
out.
We can
Can you
come.
speak out?
Yeah.
Please, can you get me?
Yes, we can hear you now.
Okay, I was saying that I was lost all through the way because the network here was really disturbing and I was not really hearing what Miss Lillian was saying. So yeah, that's how it's difficult for me.
Okay. Are you the only one representing your chapter today?
I made this. You did this.
Hi, Dubila. Dubila, are you there? Did you hear the question? Okay, probably our network. She has complained about network.
I'm
Okay, it's back now. Yeah,
Can
did you
I?
hear the
Oh,
question?
I don't know.
please, I cannot get you.
Okay, the question was: are you the only one representing your chapter? Do you have, based on your observation, do you have any of your chapter also on this call?
Yes, yes. I've seen many few of us here.
Did you say yes?
I said yes.
Okay, okay. Miss Olama, she responded as yes.
Okay, all right, great. I see a lot of questions. My phone is about shut down. People's network is bad. So this is recorded, I believe. Okay, so it would be great for you guys to go watch it or listen to it. It will help you a great deal. And again, someone said my component keep overlapping each other. Just delete the whole thing and start all over. Halima, if your component is overlapping, delete it and start all over again. Um, is the resistor always connected to the positive terminal? The resistor here is not is connected to the rail and then to the negative rail, not to the positive rail. To the any of the rails um directly under the resistor and then the negative rail. Okay. Oh, sorry, I wasn't sharing my screen. I was explaining that. Okay. All right. So again, feel free to reach out to me on Tinkercard if you have any question. If you have, I can jump on a quick call with you if I have the time. If I don't, I'll let you know when I can. I'm excited about ensuring that you guys get this information and understand how to use it. And it shouldn't stop here, right? You can always on your own. It's very fun to do on your own. Build something, challenge yourself. We did one light today. I asked you to do two. Some of you did it, or three. So on your own you can do five, six, you know and if you have the Arduino, probably you have the Arduino, you don't even know where to start. Now you've learned how to tinker it. With this tinker card, if I give you an Arduino kit, you don't need anybody to tell you how to use it. You can easily set it up. That's what tinkercad helps you do. I think I've answered most of the questions. Okay. So I'll leave it to you guys, Aurora. So I think if anyone has any questions, just let me know. I'll just go on mute now.
I have a question. Hello.
All right, Amenge, please go ahead and ask your question.
I have a question. Um. Okay. When we look at our code, we can see that we're supposed to allocate our wires in these pin numbers, right? Let me just take out this one for 13. Hello.
Can you go
Can
again? It wasn't quite clear.
you hear me?
Yes, I can hear you, Amenge.
Okay. So my question it's still based on the allocation of these wires, and we are supposed to like um like this. We're supposed to like what's the word? What's the word? We're supposed to correspond them with what the code is saying, right? But now when I connected my second LED, it still doesn't want to respond back. And I don't know if maybe I like put it, I connected the wire in the wrong pin because the adjustment is right.
Okay, I'm going to look at your code now. Just one second. So I could understand you saying you tried the second LED, it's not working. Let me look for you. You're not here. Where are you?
No, anything supposed to.
Omega, I can't see. I think. May hope I've not mistakenly deleted. Shoot. Oh, let me look for your name then. If you're not in this class.
Okay. Okay.
Okay, what's your question now? I'm on your thing, and let me share the screen. Let me see if they still let me do that. Okay. Sorry, guys. I know we're overshooting by some minutes, but I just want to respond to her. Okay. I'm looking at this. You're connected to 13, 10. Okay. So can I look at your code? So what's the question? Um,
The
because
question
it's
is,
working. It's working.
it is,
It's working, Amenge.
but I just started the.
What? Say that
Like I'm
again.
running this. Oh, now it's. Did
Yeah,
you
you
did
have
you
to
make an
click on the
adjustment?
start simulation. Then you look at the bulb. You can see the red comes on, and then it goes off, and then the green or whatever it comes on.
You didn't make any adjustment to it because I
No, I
did
didn't.
with
I
my
didn't. I
LED.
didn't touch it.
Oh, it's because okay, I see them. Okay,
So you can do another the same thing and add one more LED, and update
okay,
the
let me do
code,
that.
and then
Let me
just
do that.
always for it to work, you need to start simulation. For you to make any
Mm-hmm.
adjustments, you need to stop the simulation to do that.
Okay, wait, can I ask another question?
Yes, please.
This numbering on the Arduino board itself, like we see we have like this positive segment off
Okay.
and
Let me explain the board. Okay, good. I know what
okay,
you're trying to get at. Okay.
okay.
Uh, oh God, I've done. What did I just do? Oh no. Oh shit. My biggest nightmare. Where are you going, Tajuri? Okay. So just want to enlarge it a bit. Okay. So the Arduino board is divided into two: the digital and the analog. So for these, we'll be using the digital pins. So digital pin starts from 13 to 1, okay, or 0, because it's binary number 0 to 1. So it does 0 and 1. So it starts from 13 to 0. And we have the power pins. The power pins, reset button, 3.3 volts. Depends on what you're building. You would require different, powers. We have double grounds. The same ground here is the same ground here. Okay, and we have our vein. So there is a design I did here for a smart dustbin. We used the vein, okay, because we used this sensor. There's a sensor here that requires a vein. This one, the ultrasonic distance. So it requires a vein. So we use that. So in an Arduino class, you better understand what all the buttons and all the pins on the Arduino board is. This red one is to reset. Okay, when you have the Arduino. Okay, 1 second. Let me grab an Arduino. Just give me a minute. Oh my god. Oh my god. Yes. My hair look like that. I will be like a boy. That will start with. Hey, both of you go and tidy your room right now. Mommy, I don't want to hear you. Go and tidy your room. Mommy, I don't want watching Shaja Boy. Okay, guys. I think I need to turn on my video. Okay. So the actual green Arduino that I have, I left it at the training on my class where I run my classes. So I have the very old one at home because it's not functioning. So it's similar with what you have. It's similar with what you have, and it's the same thing, the same pins. So this is the red board, but what you have now, what's the we use now is the Arduino Uno, Elgino, or you can buy it on AliExpress, or even in Nigeria. I used to buy Arduino, the boards in Area 1 in Abuja at the time. In Lagos, too, you can get it. If you're studying electrical electronics engineering, you should be familiar with an Arduino board. This is a jumper wire, and this the same thing that we have here. Okay, so the board. So what this black cable means is a power source from your Arduino to your computer. Okay, that's what it means. Any other question? This is doing Arduino. We should have done Arduino like differently before now, but again, for the goal of this class was Tinkercad. But again, I'm just trying to throw in there that there's more to Arduino than just connecting pins and LEDs. Okay, I think have I answered all the questions. Thanks so much for having me. I'll leave it to the WAAW team to take over.
Miss Olanma, it was really nice hearing from you today and learning from you. I mean, I know a lot of us we've had our fair experiences with Arduino, and for some of us it might be new, hence the struggle. But today's class has really helped us a bit. So thank you very much for joining us today and for this insightful section. And I'm sure the fellows learned a lot, even though it seems like there's a little bit of struggle. But I know we'll all go back and would explore more on Tinkercad. Yeah, let me use that word. So thank you very much for this section. Lillian, do you want to take over?
Okay. Thank you once again, Miss Olanma, for the session. Really gained a lot. We learned a lot. Okay. My fellows in the house, my chapter leads, and everyone. I hope we all
Sorry to
enjoyed
cut you
this
in.
session.
Lillian, can I?
Okay.
Okay. All right. Bye, guys. Thank you.
All right. Thank you.
All right, and good job with the WOW team. What you're doing, I can see the numbers, and I would have loved to stay here, but I need to attend to my kids. Thank you so much for all you do. Really appreciate it. Seeing the work after 13 years, what you guys have done so much so far is mind blowing, and keep it up. This sky is still your starting point. Okay, thank you. Bye, guys.
Thank you very much. Thank you very much. Okay, to our fellows, please, your appreciation to Miss Olanma, you can drop them in the chat room. Thank you once again, Miss Olanma. Okay, so we are far behind time, and I know that we should be keeping to time. Thank you for your patience for staying this long. We're going to rush over the rest of this session so that we can all go and have a nice rest. So up next on our slide is recognizing June outreaches. So across our WOW Foundation chapters this month, we have 13 impactful outreaches as of yesterday. And it was conducted across 9 chapters that are in Nigeria, Ghana, Namibia, Congo, Malawi, and Ethiopia. We thank all of us, all our chapter leads, all our fellows who took it upon themselves to carry out outreaches this month. We appreciate you. So, as a result of your outreach, we empowered over 711 girls. Please make noise in the chat room. Your claps, your reactions should roll in now. And so we inspired these girls and equipped them with STEM knowledge. And present with them were 41 teachers across the globe, across the chapters that had their outreaches this month. Directly, we engaged and impacted more than 1,100 students. So both male and female students, men that want to support the women in STEM, and everyone, students across the countries where we had our outreaches. We had 1,100 students. Please make some noise in the chat room. Thank you. I see all of it. Okay, next one. So as we are recognizing our June outreaches, we have the University of Mines and Technology, Takwa, Ghana. Make some noise for this particular chapter for having outreaches this month. And next is the Federal University of Technology, Owerri, Nigeria. Please, let's appreciate them in the group, in the chat room. It's not easy. Next one is Chukwuemeka Odimebu Ojukwu University in Nigeria. And the next is the University of Nigeria, Nsukka. Next on our list is JEDS University Chapter, Namibia. I don't know the full acronym, the full meaning of that acronym there, but of course, the university is in Namibia, please. Okay. And the next one is Addis Ababa University Chapter, Ethiopia. A round of applause for them. The next one is the University of Ibadan Chapter, Nigeria. Nice one, guys. Thank you very much for carrying out outreaches. And next one is ULPGL Chapter, Congo. The next on our list, which is the last but not the least, is the Malawi University of Science and Technology, Malawi. Thank you, admirable chapters, for carrying out outreaches this month. We await and we hope to see more of these outreaches, more of these impacts. Let us shine our light out there and help these girls come to realize that they have more of STEM in them. I like that line, actually. Okay, so we're going to be doing something quite interesting. This is the month of June, and we want to recognize chapters who have done numerous outreaches between the months of January to June. This is the first half of the year. So we want to recognize those chapters that carried out a number of outreaches. We appreciate everyone. We appreciate all the chapters, but this chapter stood out by carrying out numerous outreaches in the first half of the year. And so, to whom much is given, much is expected. As we're recognizing you, dear chapters, we also want to see you do more. Okay, so the first on our list is the Nnamdi Azikiwe University, Awka, Nigeria. They had a total of 4 outreaches from the month of January till now, which is the month of June. A round of applause for them. Now the next is the University of Bamenda, Cameroon. They also had a total of 4 outreaches in this first half of the year. Please, a round of applause for them. The next is Bayero University, Kano, Nigeria. They had a total of 5 outreaches in this first half of the year. Let's clap for them. React in the group, make some noise so that you also will be celebrated. Okay, and the next, which is supposed to be the first runner-up, is the Federal University of Technology, Owerri. They had a total number of 7 outreaches between the first half of this year, and they have been doing amazing. So, who is the leading chapter? Which chapter is the leading chapter? Which chapter had the most outreaches from the month of January till now? You can guess. Please put your guesses in the chat room so that we'll know which chapter is this. Which chapter is this? I want to see some guesses in the chat room before I release the bomb. Let's see. Let's hear you. Keziah said Omat's chapter. Someone said Namibia. Shagamu chapter. Wow. Okay, Uma chapter. Interesting. So 5, 4, 3, 2, 1. And the chapter is the University of Mines and Technology, Takwa, Ghana. Please make some noise in the chat room. They had a total of 9 outreaches. I love that. I love that. I love that. Make some noise. Wow, I can see the excitement in your tone. Thank you very much. Okay, they had a total of 9 outreaches. Please make some noise for this chapter. They were amazing. And to that, they are the leading outreach chapter of the month 1 and of the first half of the year, which makes them the winner of the June chapter of the month and the first half of the year. Please make some noise for this chapter. Clap and react in the chat room. Okay, so shout out to our top 5 chapters by outreaches from the months of January to month of June. You guys did wonderfully well. You did amazing. And we are waiting to hear and see more of your impact to the world. Okay, let's rush over our reminders and announcements. Outreach reporting, don't forget to submit your completed outreaches using the outreach reporting form. I'm always hammering on this in the group. Do not forget to fill the outreach proposal form first. Then you'd let us know when you're going for your outreach, so that when you are done going for the outreach, you report back to us that, okay, this outreach I did, I have done it, and this is the report of the outreach I carried out, right? So please note that best chapter of the month is usually reviewed and selected based on these submissions. So you might have 100 outreaches in 1 month, but if you end up reporting maybe 3, you did not report the rest, we might not necessarily know that you had outreaches. We may know, but because it's not in our database, we won't reflect it. We will not reflect it. So please report all your outreaches. That report is very, very important. Very, very important. So to buttress, for all of us who have not taken the time to read through the criteria for choosing the chapter of the month, there are now 5 key criteria for your chapter to be chosen as chapter of the month. And the criteria are: 1, you must do as many outreaches as possible. Do as many outreaches as possible. Second of all, you must post that outreaches in your social media. Must, M-U-S-T, must, in your social media, while tagging WAAW Foundation, so that we can be able to see it, you can come across it, right? Now, the third one is you must submit the names of your fellows who are supposed to come for this fellows meetup. Chapter leads and assistant chapter leads, please take notes. You must submit the names of your fellows who are supposed to be in this call right now. Please note that our fellows meetup is always, we are not changing it anytime soon, always the last Saturday of every month. The last Saturday of every month. So please, we'll keep buttressing on the reminders in the group, but then also have it at the back of your mind that fellows meetup is last Saturday of every month by 5 p.m. West African time. Okay, so back to, sorry for the deviation. The fourth one is you must complete the survey after fellows meetup survey form. So we'll be dropping the link in the chat room now. So you do well to fill that form now as we are in this call, while you're listening to the rest of the reminders and announcements. Okay, so our next monthly fellows meetup will be held on Saturday, July 26th at the usual time, which is 5 p.m. So please mark up your calendars and plan to attend. Don't forget to fill the feedback survey for this session. Please don't forget to fill the feedback survey for this session. And if you would like your chapter to be featured for the July edition, I don't know if you can remember, sometime in May, we featured someone to speak on their outreach. So if you have a very fascinating outreach experience that you want to share with everyone on this meetup, you can reach out to me. Reach out to me in my DM. I'm very open because I have friends here. Some have even promised to come and take me abroad. So I have friends here. So I'm very friendly. You can come to my DM. Let's talk as friends that we are and see how to get you on board. Come and share your outreach experiences with others so that they can also learn, probably copy from you and do theirs as well. So please reach out to me on WhatsApp. Let's talk about it and get you on board. Thank you, everyone. Thank you very much, everyone, for your patience staying up to this time. I know we're always running behind time, but please, I mean, it was a very exciting session, right?
Sorry,
Am I
Lillian, let
right?
me cut you in. Please, can we turn on
Okay.
our video for our virtual photo shoots, please?
Yeah, exactly. Turn on your video so that we can have a virtual photo shoot. Don't say anything.
Please turn on your video now. You don't want me to see your face.
Ooh, see beautiful faces. And the latest graduates, Evelyn. Evelyn, you didn't invite us for your sign out. Nice faces, beautiful faces. Amengi is such a pretty girl. I mean, everybody is pretty. Queen Danny is also a pretty girl. Hmm. Ornella, I'm seeing your face for the first time. Oh. Hmm. Hi. Oyindamola. Hey, Deji. Deji, that name is ringing a bell. Okay. Josephine, I see you. Ola Ahmed, I'm not seeing you. Why? Belinda, I'm not seeing your face. Keziah.
Okay, thank you.
Please fill up the after meetup survey form before you leave this call. Thelma, hi. Happy, hi. Sammy, hi. Okay, Jessica, you done? And please, let's all be active on the group today so that we can share ideas. We learned a lot today. Let's go and share with others. So please, we are going back to the group chat, the WhatsApp group chat now, to share some ideas. Are we good? Hello, everyone. Can anyone hear me? Please react if you can hear me. Oh, God. Hi. Okay. So thank you everyone. Let's not linger this. I think network issues is kicking people out. So thank you everyone for being here. Thank you for your patience. Thank you for everything. Let's do more next month, this coming month. And so that I say a happy new month in advance. Together, of course, we know we keep achieving what? Great things. So thank you, everyone. Bye. Let's meet up in the chat, in the WhatsApp group now. Bye. Bye, everyone. Bye, everyone. Bye. Here. Okay.